Good morning, Year 12 single mathematicians. Hope you're all well. Just going to continue with Chapter 11 in the textbook, 11.2, which we're still doing variable acceleration, but we're going to need to use differentiation to help us work out and change between displacement, velocity, and acceleration. So the learning objective today is to use rates of change to work out displacement, velocity, and acceleration. And just a few reminders from Suvat how to work out different things. So from our studying of constant acceleration, we had a few definitions for the following. So we had acceleration was equal to change in velocity over change in time, and we had velocity was change in displacement over change in time, and those worked for as fractions in for constant acceleration, but we do need to know what these change into for variable acceleration. So I'll also remind you that last time we stated that the gradient of a velocity time graph was acceleration, and you should know an area of pure mass which is linked to gradient, and that is differentiation. So the equivalence now for curves and for variable acceleration is A is differentiate with respect to time, dv by dt, the rate of change of velocity with respect to time. And you should know as well from previous chapters that the gradient of a displacement time graph is velocity. So velocity would be ds by dt. And you need to know both of these. Okay, let's keep going. So we've got an example. A particle P is moving along the x-axis, so it's moving in a straight line. At time t seconds, the displacement x meters from the origin is given by this formula: x equals t to the 4 subtract 32t plus 12. And they'd like you to find out what the velocity of P, the particle, would be when t is equal to 3. So not a bad start for this, is kind of what you'd expect. So the only difference is they've used the letter X rather than the letter S for displacement, but that doesn't change anything. Velocity, to go from displacement to velocity, we have to differentiate, and it would be in this case dx by dt. Differentiate the displacement. And we get 4t cubed, bring the power down, knock one off the power, 32t, the t disappears, and 12 differentiates to 0. And then this would be the formula for velocity, and that would be the formula to work at the velocity at any time you like, and we want when t is equal to 3. So v would be equal to 3 cubes subtract 32. Type that into the calculator. Gives you 76. And that would be meters per second. And that'd be it. Part B. I'm going to find the value of t for which the particle P is instantaneously at rest. In other words, v is equal to 0. And remember, we've got the formula for velocity above. So we've got 4t cubed subtract 32 needs to be equal to 0. How do we solve this? Should we add 32, make t the subject, so add 32. Divide by 4. And then cube root. To get t is equal to 2 seconds. And that would be the time when p is instantaneously at rest. The last part is to find the acceleration of p when t is equal to 1.5. Now we have not got a formula for acceleration, but we should know that acceleration is dv by dt. Differentiate the velocity. Go all the way back to our velocity formula and differentiate. What do you get? You should get 12t squared. And now this is the variable acceleration part. This changes depending on what values of t I substitute in. If I substitute 0 in, or 1 in, or 5 in, it gives me different values of t. That's the variable bit I want when t is equal to 1.5. So when t is equal to 1.5, the acceleration is equal to 12 1.5 squared. Type that into my calculator. Gives me 27 meters per second squared. And that would be it. And that's all you need to be able to do in this particular subchapter. So I'm going to set the work that I'd like you to try. If you all find exercise 11b, it's on page 186. I'd like you to do questions 2, 3, 4, and 5. So questions 2, 3, 4, and 5. Once you've done those, upload them to the class notebook. Remember to mark your answers with the ones in the back of the book. If you're having any problems, you can ask for help on the Teams chat, and I'll see you next time.